Dear judges, this is Haowen Yang from Pro School, and now I'm presenting the computation fluid model Frisbee for you. Let's get into it. I'm going to be presenting my motivations, the goals to research, the methodology, the software development process, also the validation process, eventually the result and discussion, also the conclusion. How do I get into this about Frisbee? So Frisbee is a very popular outdoor entertainment and sports activities since I was very young. Also, the physics behind the Frisbee flight is still not very clear. Also, we don't have the tool to predict the trajectory, the maximum range of Frisbee accurately. So let's just come up with our goals here. First of all, we need to understand the physics behind the Frisbee flight. Also, we need to develop a computational software to predict the trajectory of Frisbee. Eventually, we need to investigate the parameters affecting Frisbee flying, then get the optimum operation condition and optimal design. I think at this stage, it's necessary to talk about the math behind it. So I especially read the Haowen 2003 essay, which came up with this expression for the coefficient. The coefficient is a very important term in the Bernoulli's equations. So with the Bernoulli's equations, we are able to find the force specifically. With the force, we're able to find the acceleration by implementing the Newton's second law. Also, with the acceleration, we need to find the velocity. At the same time, with also the position at all the time instants. Since we're using the Euler's principle here, so we will have all these big chunk of x and y coordinates, and with these data, I'm gonna be able to plot the curve. So as I said, we need a good software to predict the trajectory. So first of all, we are coding inside MATLAB, basically putting all the math into it so that the computer do the work. Also, the graphical user interface looks like this before everything is put inside of it. This is how it looks like when the software is running. Let me just do a quick demonstration for you how this one works. As you can see, I already pre-input some of the parameters here. All you need to do is just click the start button and just give it a second. It's going to calculate a beautiful trajectory for you, as you can see right here. At the same time, you're going to get the maximum height of this whole flying process. Also, you're going to get the distance. Okay, with the model, we need to make sure that our model is valid. So I have this data from BAMAC 2010, which is a published data you can find on Google Scholar. And with my data from my software, as you can see, the data from the paper is really close to my data. So I can say that they're pretty accurate. So now it's getting to some discussion about what we come up from those softwares. So first of all, we're testing the effect of attack angle, alpha. Then we can find the optimum with the maximum range at angle of 10 degrees. Also, the height increases as the angle increases. Also, we can find the initial speed velocity. The distance increases as the initial speed increases. Also, the maximum increases at the same time. Eventually, we also have the effects of diameter, even though we have the international dimension of Frisbee, but we still kind of want to see how that diameter would affect the behavior of Frisbee. So we have the optimum of distance at the diameter of 0.34 meters, and also have the maximum height increases as the diameter increases. Also, the effects of horizontal wind speed. The distance increases as the horizontal wind speed increases from -5 to +5 meters per second. At the same time, the maximum height increases as well. We also have the effects of vertical wind speed. So the distance increases as the vertical speed increases. Also, the maximum height increases as the vertical wind speed increases at the same time. So let's get into some of our conclusions that we can get from this whole research. First of all, we successfully developed a computational software for public use. As you can see, I just demonstrate that. And also, we can explore the physics behind the Frisbee flying. We also can find the optimal operation condition with attack angle of 10 degrees. Also, we find optimal design, diameters of 0.34 meters. So we're coming to an end. Enjoy Frisbee and thank you for your attention. Bye-bye.